Well, good evening. I'm particularly honored this evening to introduce a very special person for this talk, Provost Naomi Oreskes, Provost at of the San Diego Sixth College of the University of California, is here to speak to us. That college focuses on the intersection of culture, art, and technology. A very interesting combination. Before that, she was professor of the history of science, and in fact, she started out as a scientist, a geologist. She got her PhD from Stanford, and then moved on to the history of science, and carried out research, and continues to carry out research on the historical development of scientific knowledge, methods, and practices in the earth and environmental sciences, and on understanding scientific consensus and dissent. Her research was referenced in the award-winning film An Inconvenient Truth, and it documented a scholarly consensus on 2 points. The Earth is warming, and humans are the cause. So her research focuses on the development of scientific knowledge, methods, and practices in the earth and environmental sciences. She's the author of books, an interesting topic, The Rejection of Continental Drift, Theory and Method in American Earth Science, and now a new book, Challenging Knowledge, How the American People Have Been Misled About Global Warming. At a time when there are some people, even some scientists, who loudly promote ignorance and twist the truth, and who would gladly shortchange the future of this planet and the quality and well-being of future generations, we're particularly fortunate to have people like Naomi Oreskes, who are courageous and willing to explore carefully the reason, the underlying truth of these important issues of our time. Her topic this evening is Merchants of Doubt, How a Handful of Scientists Obscure the Truth About Climate Change. Well, thank you and welcome to Naomi Oreskes.
Thank you. It's really an honor and a privilege to be here tonight, and I want to thank the folks who have invited me and all of you for coming tonight, and especially because, as I was telling Steve, doesnt, and a few others, I'm a Brown dropout, which is important because I often tell my students you can drop out of the Ivy League and still have a life. So it's nice to be back in Rhode Island after all these years. So I have this slightly obscure title, which the organizers told me was too obscure for the poster, but I left it up there anyway because by the end of the talk, it will be clear what I mean by it. This talk is drawn from my new book, as our dean just told you, which is coming out in the springtime. I'll talk more about that in a minute. So for the past several years, I've been studying, for quite a few years now, I've been studying the issue of scientific consensus and dissent. And I'm particularly interested in the questions of how scientific communities come to consensus on contested topics, how scientists decide when there's enough evidence to say that something is known scientifically. And I take that to be an important question both intellectually, in terms of understanding how science works, and also politically and socially in terms of us as a community, as a country, in knowing when we can rely on scientific knowledge and how to think about scientific debate. So I've had this interest for a long time, but a few years ago I became interested in the question of whether or not there was a consensus among scientists about the question of anthropogenic global warming, and I've given many talks now over the last 3 or 4 years on this topic. And being a historian of science, but with a scientific background and training, I was particularly interested in what we could call the epistemic basis of consensus, that is to say, the evidence which leads scientists to say that something is known. And so when I would give talks, my initial impulse, like anyone trained as a scientist, would be to cram the talk with facts. And so I would focus on many of the facts of the history of science, which it seemed to me were important for us to understand in order to understand how scientists had come to their current state of knowledge, and also to understand that global warming was not just the latest environmental fad. So my talks would generally start with this man, John Tyndall, who in the 1850s first established the concept of a greenhouse gas. That is to say, he showed that certain gases, namely carbon dioxide, water, and some others, have this property of being essentially transparent to visible light, but relatively opaque to infrared. And so therefore, water and carbon dioxide warm the planet, warm our planet, which would otherwise be much, much colder than it is if it were not for carbon dioxide and water in the atmosphere. The first person to recognize that greenhouse gases from burning fossil fuels could have an impact on the Earth's climate was this man, Svante Arrhenius, who first suggested in the early 1900s that greenhouse gases from burning coal could warm the planet. And he, in fact, did the first calculations of the effect of doubling CO2, which he estimated to be between 1.5 and 4.5 degrees C, not very different from what we would now believe today. Of course, Arrhenius was a Swede, so he thought global warming would be a good thing. But that idea was challenged by this man, Guy Stewart Callender. There's a wonderful new biography of Callender by my colleague Jim Fleming, who's up the road from here in Colby College. If you're looking for more speakers, Jim Fleming is a great speaker as well. And Callender not only argued that global warming might be a bad thing, that it could disrupt the Earth's climate, but also that the increase in carbon dioxide actually was already detectable in the 1930s. So he was really out in front on this question. Well, this issue of whether or not carbon dioxide was already increasing was taken up in 1958 by this man, Charles David Keeling, working as part of the International Geophysical Year. And Keeling recognized that knowing whether or not carbon dioxide in the atmosphere was really increasing was crucial to understanding whether or not global warming would ever be a problem. And being at an oceanographic institution, Keeling recognized that just because we were burning fossil fuels didn't necessarily mean that the atmospheric concentration of CO2 would increase, because it was possible that that CO2 would be taken up by the oceans, could be dissolved in the ocean, or it could be taken up by plants. And so to answer the question of whether or not it was actually going to the atmosphere, you needed to measure it. So Keeling began to do that in 1958, and within a few years he had shown that in fact there was already a detectable steady rise in carbon dioxide, and by the year 2000 we had what we now know as the Keeling Curve, which shows one of the clearest signals probably ever collected by a geologist in the history of mankind, right? I mean, this is an incredibly clear graph showing that despite seasonal variation, there is a very steady climb in the amount of carbon dioxide in the atmosphere. So this showed that the CO2 was not being entirely absorbed by the ocean. Some of it was, but not all of it. And it was not entirely being taken up by plants. Some of it is, but not all of it. Now, one of the interesting things I found in my historical research is that already by the early 1950s, Keeling work was gaining attention, and people in Washington, D.C. were beginning to talk about what it might mean from a policy perspective. So this is either encouraging or discouraging, depending on your point of view. Being a historian is sometimes depressing because you discover that we actually knew all this stuff a long time ago and didn't do anything about it. So in 1965, President Lyndon Johnson wrote this in a special message to Congress. This generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels. Lyndon Johnson knew that in 1965. But Lyndon Johnson also had a lot of other problems on his plate, so the issue didn't really gain political traction in the 1960s. It didn't even really gain all that much scientific traction, but by the 1970s, with improvements in scientific computer modeling and the Arab oil embargo, the issue came to the fore again. And the US Department of Energy began to fund work on developing climate models, continued to fund Dave Keeling's work in CO2, and so by the late 19th century, a consensus emerged among the scientific experts that given the rise of CO2 that Keeling had documented, so by the late 70s we already knew that CO2 was rising, that given that rise, sooner or later global warming would occur. And indeed, in 1979, the US National Academy of Sciences issued a major report on this issue, and in the press release for the report they wrote, quote, "A plethora of studies from diverse sources indicates a consensus that climate changes will result from man's combustion of fossil fuels and changes in land use." So this was the National Academy of Sciences in 1979. So I hope if I convince you of nothing else tonight, you will at least understand that concern over global warming is not a fad. This is something that scientists have been working on for many decades and have been building their understanding of for a long time. Sometimes I also get emails or angry questions when people say, well, science isn't about consensus. Think about Galileo. Think about Copernicus. Well, it's true that in the 16th century, when there only were about 15 astronomers on the whole planet, one individual could represent a very significant fraction of the total scientific effort. But that's not really true today. Modern science is a different kind of beast. And consensus is extremely important in the modern world because it represents the collective wisdom of the experts who have studied a problem. So this is the US National Academy of Science. In history, we sometimes talk about actors' categories, that is to say, categories that we're not imposing on history, but that people themselves used. So consensus is an actor's category. So if we go back to 1979, we can say that there was already a consensus that global warming would occur, but the big question was when. How soon would these changes come into effect? And in the late 70s, most scientists who were writing on it at the time thought, well, probably not before the 21st century. And there were various estimates, but many of the estimates were 2030, 2040, 2050, something like that. One scientist I know who briefed the Carter White House on this topic says he remembers one of the people in the White House saying to him, well, when is all this going to happen? And he said, well, maybe in about 40 years. And the politician, the official in the White House said, get back to me in 39. But the surprising answer was much sooner than scientists expected. And again, we've heard a lot of noise lately about exaggeration of scientific claims, alarmism, hysteria, but actually, I believe the history shows that scientists have actually been conservative in their estimates and that global warming has in fact began to unfold faster than scientists thought. Because what they found, the surprising answer, the answer that really took the scientific community aback, was that within a few years, the evidence of global warming had become detectable. Some of you will recognize this man. This is Dr. James Hansen of the Goddard Institute for Space Studies. And in 1988, James Hansen and his colleagues published a major paper in the Proceedings of the National Academy of Sciences, and then testified about it in Congress, in which he declared that he was 99% certain that climate change caused by human activities was detectable. Now, that wasn't to say that it was gigantic or huge or catastrophic, but that you could detect the signal above the noise, that you could see the evidence that these changes were beginning to take place. And this was in 1988, only 9 years after the Academy consensus that global warming would happen. Now, in 1988, a lot of Hansen's colleagues disagreed with him. That is to say, they thought he had gone too far. They thought he was out on a limb. They weren't convinced that the signal was, in fact, detectable over the noise. But within a few years, Hansen was vindicated. By the early 1990s, virtually all climate scientists agreed that the temperature record did show that a clear signal was beginning to emerge out of from the instrumental temperature record. We have data from instruments going back to the middle part of the 19th century, and by the early 90s, this signal is beginning to show up. In 1995, this was summarized in the second assessment report of the Intergovernmental Panel on Climate Change, which was organized explicitly to address this question. What do we actually know about this problem? And in 1995, the IPCC, representing the consensus of people actually working and studying on climate, quote, the balance of evidence suggests a discernible human impact on global climate. So again, it's not hysterical, it's not catastrophic, it's not alarmist, but it says when we look at the evidence and we weigh it and we say, what does it all add up to? When we weigh the pros and cons, what we find is that the balance of evidence suggests a discernible impact. So the fingerprint, that human fingerprint, which is in the poster for this lecture series, that fingerprint had become scientifically detectable. That was in 1995. Now, it's important in science, one of the questions that I always think about when I'm studying historical things is, how do scientists weigh evidence, and how do scientists explain that evidence? And it's often the case in science that if you have evidence of something going on, but you don't know why it's happening, then that's kind of problematic. And if anyone's interested, there was an incredibly interesting piece about this issue with respect to the question of electromagnetic fields in last week's Los Angeles Times. So I'm not going to talk about EMF today, because that's even more controversial than climate change. But if you're interested, check out the Los Angeles Times health section. And it's important for the following reason. So scientists now were convinced that the evidence showed global warming was occurring, and they had predicted it. Well, why had they predicted it? They had predicted it because they understood that basic physics showed, or basic physics told you, that because carbon dioxide was a greenhouse gas, if you increase greenhouse gases in the atmosphere, you expect climate to change. And that's what happened. And the IPCC explained that in this not very helpful diagram, and somebody could be forgiven for not understanding it, but the basic argument is that the IPCC said, look, we know that there are various things that affect climate. The sun is obviously important. Land use, reflection off ice, various things like that, also important. Aerosols, also important, mostly have a cooling effect, although not entirely. So we have these various cooling effects, we have heating from the sun, and we have various things that heat the earth. And we know that CO2, methane, and some other greenhouse gases have a strong heating effect. So we expect this to happen. We understand the mechanism, and it's happening. Now, so that's a nutshell version of the, the short version of the history of the consensus, of coming to a consensus on climate issues. But whenever I spoke about these things, invariably there would be skeptics in the audience. And often those skeptics were aggressive and hostile and sometimes rude. And almost invariably they would ask one of 2 or 3 questions that were always the same. And one of them was, well, how do we know it's not the sun? Said in that kind of tone of voice. And there's sort of this aggressive sort of resistance, this aggressive sort of assertion that it should be the sun. So I would very patiently explain the difference between the predictions of what global warming would look like if it were caused by the sun versus what it would look like if it was caused by solar irradiance. And I was warned not to go into too much technical detail here, but if anybody's interested, the short version of this is that if the Earth were being heated by the sun, we expect the whole atmosphere to warm up as the sun's warmth is coming from outer space, heating the atmosphere. But if the Earth is being heated by increased greenhouse gases, then something different happens. Solar radiation comes in, greenhouse gases are transparent to visible light. The Earth absorbs the heat and re-radiates that heat, re-radiates that energy as heat, as infrared. And we know, by definition, greenhouse gases tend to be fairly opaque to heat, opaque to infrared. So in that case, there's a very different prediction that you would get from those 2 different causes. If the sun is heating the atmosphere, we expect the entire atmosphere to warm up. If greenhouse gases are trapping heat from the Earth, not the sun, then we expect the lower atmosphere, the troposphere, to heat more, and the upper atmosphere, the stratosphere, to stay the same or cool. Well, NASA has used satellites to measure this issue, and the satellite data clearly demonstrate that the troposphere is warming, the stratosphere is cooling, and this is consistent with the predictions of what you would expect if this is happening because of greenhouse gases, not the sun. There are some other arguments as well that we can go into if people are interested, but the point is that we do have evidence to explain and support this understanding. And I should say, I forgot in the very start of this talk, I want to acknowledge my co-author on this project, Eric Conway, who is the historian at the Jet Propulsion Laboratory in Pasadena and has worked extensively on the history of satellite measurements of the atmosphere. Now, the second question I would often get was, well, how do we know the carbon dioxide doesn't come from volcanoes? Okay, fair enough. We do know that carbon dioxide can come from volcanoes. When volcanoes erupt, they do emit carbon dioxide into the atmosphere. So I would explain the stable isotopic evidence that the CO2 is produced by burning fossil fuels. We talked again about fingerprints. How many people here know what isotopes are? Oh, mostly. Okay, good. So you know that atoms have different isotopes, and those isotopes are very useful because the isotopic signature of a compound can vary depending upon where that compound has come from. And one of the things that's very well established scientifically goes back to the 1950s when the US government supported a lot of research on isotopic signatures because of isotopes produced by the atomic bomb. So this is well-established science produced by people associated with the nuclear weapons program, not radical environmentalists. We know that the carbon dioxide that comes from fossil fuels, this carbon, is very different than the carbon that comes out of volcanoes. And in fact, when scientist Goshen Brand studied this question, so here's the Keeling curve, but extrapolated back through ice core data. Here's the Keeling curve, show the steady rise of carbon dioxide over time. And look at this, a steady decrease in the carbon-13 value. And that is inconsistent with coming from volcano. And again, to try to explain this without spending too much technical detail, one of the things we know about plants is that plants selectively take light carbon out of the atmosphere. They concentrate carbon-12, and they don't like carbon-13. So if you burn plants, or if you burn fossil fuels produced from plants, like coal, they're depleted in carbon-13. So therefore, you would expect that the carbon-13 value of CO2 associated with fossil fuels would be less, and that therefore you would expect the value of carbon-13 in the atmosphere to fall as we add to it carbon dioxide from burning fossil fuels. And that's exactly what has happened. So this prediction has exactly come true. And you can see it's practically a mirror image. As the total CO2 goes up, the carbon-13 falls. You really can't ask for better data than that in science. So I could answer these questions and explain the science that answers them, and explain how scientists had sorted through these problems. But what became interesting to me was how similar these questions always were. And as I said, the kind of aggressive, kind of almost denialist sort of tone, you know, the sun did it, volcanoes didn't, so almost like looking for some excuse not to believe that what was going on was caused by mankind. And the other thing that was interesting is that often when I got these questions, the people seemed to sort of know what they were talking about. They knew the difference between the troposphere and the stratosphere. So it was clear that these weren't ignorant questions. In some cases, they were actually rather sophisticated. And as I said, often the question began, isn't it true that? Or isn't it the case? So I started becoming interested in the following question. Where were people getting all this skeptical misinformation from? It just seemed like it wasn't just coming out of nowhere. It was too similar and too aggressive to seem and feel spontaneous. And of course, meanwhile, I was also getting aggressive email from people who in some cases were citing websites. So the great thing about being a historian is everything is raw material. So I started looking into this question. One more piece to this story. So around the time that I was starting to get deeper into this material, the Yale Project on Climate Change produced a poll in conjunction with the Gallup organization, the Clear Vision Institute poll. This was in 2007. This project continues, and you can go to their website and get the updates. And at that time, 72% of Americans were completely or mostly convinced that global warming was happening. However, 40% of us thought that scientists were still arguing. And I thought this was a really weird result, right? Because, you know, you could argue that no science is ever certain. There's always uncertainty. It didn't seem to me shocking that Americans were not entirely convinced of the reality of global warming, but it did seem to me shocking that 40% of us thought that scientists were still arguing when it was totally clear that that was completely incorrect. And my own work had shown that, in fact, there was a scientific consensus going back to the IPCC report in 1995. And I had written about that and published this article in 2004. So my historical work showed that scientists had had a consensus that warming would happen since the late 1970s. They had a consensus that it had become detectable since the early to mid-1990s. And yet, nearly half of all Americans had this impression that there was a raging scientific debate. So where did that disconnect come from? How is it possible that scientists, from their perspective, had actually answered these questions and settled them, but many of us had the impression that there was this gigantic climate debate? Well, so the short answer, and the long answer is in my book, the short answer is that this is the impression that a small but powerful group of people, aided and abetted by well-funded think tanks and a compliant mass media, have wanted us to have. And as I just said, this is the topic of my forthcoming book, which is also the official title for this talk, Merchants of Doubt. And we did change the title. I realize I have to update my webpage. The original title was the one you just gave, Challenging Knowledge. I think we argued for months and months about what the title of the book should be. So anyway, the title is Merchants of Doubt. And it tells the story of how a small group of scientists, who were not climate scientists, but actually mostly nuclear physicists who had worked on the Cold War weapons programs, how they exploited normal, legitimate, true scientific uncertainty in order to create the wrong impression about the scientific knowledge, not just about global warming, but about a whole set of environmental issues, beginning with tobacco going through acid rain, the ozone hole, and then building up to global warming. And in the book, we show this pattern of how the same strategies were used to generate doubt and to exaggerate uncertainty about these issues. In the book, we also explain, we were talking about this, some of us were talking about this at dinner, that they did not do this for money. When I first started talking about this, most people assumed that this would be a story of greed and corruption, but it's not actually a story about money. It's really a story about ideology. And the ideology is the ideology of laissez-faire governance and an opposition to government regulation in all forms, which explains why it's not just about global warming. So what I'd like to do now is just give you an extremely brief summary of the book, brief enough that I hope you'll still want to read it. And then to focus here tonight on the question of how we, and by we I mean the public and the mass media, get taken in by these claims of scientific uncertainty. And the argument that we make at the end of the book, which I'll present to you here today, is that we get taken in part because we have a wrong view of science, an incorrect view of science. And so I'll end the talk then with a short reading from the conclusion of the book. So as I said, in the book we track the story of a small handful of Cold War physicists, a relatively small number of people who had a big impact because they were powerful and influential, and because they, through their Cold War work, were known by admirals and generals and senators and governors, and even were invited to the White House to brief presidents because they were very influential and important people. But instead of promoting the results of their own scientific colleagues' work, instead they promoted the idea of doubt, of the exploitation of scientific uncertainty to avoid regulatory action on a set of issues, as I've said, ranging from tobacco control to global warming. So there are three principal players in the story and one think tank. The three principal players are these men shown here. On the left, Robert Jastrow, an astrophysicist who was the head of the Goddard Institute for Space Studies. So you see, these were all extremely prominent people, and that's part of the story. If they hadn't been prominent, I don't believe they would have had credibility with the mass media. They wouldn't have had access to the corridors of power, but they did. In the middle, Frederick Seitz, the former president of the US National Academy of Sciences, president of the Rockefeller University, and also a consultant to the R.J. Reynolds Tobacco Company. And on the right, this man, known to quite a few people in this audience, William Nirenberg, a nuclear physicist and the longtime director of the Scripps Institution of Oceanography. Well, you never liked those guys anyway, right? And the think tank is the think tank that these three men founded in 1984, the George C. Marshall Institute. They founded the Marshall Institute originally to defend Ronald Reagan's Strategic Defense Initiative against the scientists' boycott of it. Some of you will remember that in the early 1980s, when Ronald Reagan first proposed the idea of strategic defense, or Star Wars, there was a massive reaction against it by physicists and engineers who thought that it would be politically destabilizing and was generally a bad idea. Jastrow, Nirenberg, and Seitz were part of a small minority of physicists who supported SDI and wanted to create a mechanism to counterbalance the publicity that mainstream physicists were getting in the mass media. And so they created the Marshall Institute in order to get their views heard, and by demanding equal time from the media. So when the media quoted Carl Sagan and Hans Bethe and many other physicists saying SDI is a bad idea, it will be destabilizing, it could provoke the very first strike that it's supposedly intended to prevent, these men would call up newspapers and say, well, excuse us, but we want equal time for our views. And they got it. So from 1984 to 1989, for about 5 years, they spent most of their time, and Nirenberg and Seitz were retired. Jastrow was retired at this point too. They were all retired from the jobs they had had for most of their careers, and they dedicated themselves to defending SDI. And they did this, and this is one of the, this story is filled with paradoxes and ironies. Later, they would accuse environmentalists of being alarmists, but they themselves defended SDI by promoting an extremely alarming view of Soviet strength, a view that was later shown to be quite incorrect, and a very alarming view of American weakness. I'm just going to go straight to the slide here. So just to give you one example of the kind of alarmism that they promoted, in 1987, Robert Jastrow published this article in the National Review under the title, "America has 5 years left." I mean, as alarmist as Al Gore or Jim Hansen have ever been. I don't think they ever said we only have 5 years left to deal with global warming. But in this article, he insisted that the Soviet was about to overtake us in military strength, and that unless we improved our military capacity immediately, within 5 years, the Soviet Union would overtake us, dominate Europe, dictate terms in the Middle East, and essentially take over the world. Well, that didn't turn out to be true. Now, at the time, Fred Seitz was working as a consultant to the R.J. Reynolds Corporation. And as many of you know, and has been written about in several books, including a wonderful book by Alan Brandt, professor at Harvard, called The Cigarette Century, the principal strategy that the tobacco industry used to defend tobacco against the mounting scientific and medical evidence of its harms was what we refer to in our book as doubt mongering. That is to say, to insist over and over and over again that the science was unsettled, that we didn't really know, that there were very substantial scientific uncertainties, and that therefore it was premature for the government to act to control tobacco. We just didn't know was their mantra. So in 1989, these two strands, the Cold War defense of SDI and Seitz's work with the tobacco industry, merged. Now, 1989 is not a coincidental year because, as some of you will remember, it's also the year that the Cold War ended. The Soviet Union fell apart, and shortly after, the Berlin Wall fell. So you might have thought that Jastrow and Seitz and Nirenberg, whose whole reason, the raison d'etre for the Marshall Institute, the whole reason they had come together to create this institute was to defend the United States against the Soviet threat. Well, suddenly there was no Soviet threat. And these men were all, by this point, in their late 70s or even early 80s. They'd had very successful scientific careers. So you might have thought that they might have said, great, we won the Cold War. Life is good. Let's retire and play golf. It's not what they did. Instead, they found a new enemy. And that new enemy was what they called environmental extremism, what they considered to be the exaggeration of environmental threats and the insistence that government regulation was needed to control these threats. So basically, they began to take on a set of environmental issues, starting with acid rain, then the ozone hole. They became engaged in a big argument in the mid-90s about secondhand smoke, and finally global warming. And then later, they actually returned to an old argument about DDT. So these are, in the book, we have a chapter on each of these debates. In every single case, these men denied the severity of the problem, and in every single case, they insisted that the science was too uncertain to justify government intervention in the marketplace. And I think this is really important because I think it begins to show an important pattern. It could be that the science of the ozone hole was uncertain. That might have been the case. It could have been true. I'm not saying it was, but it could, in theory, have been true. But acid rain and ozone and tobacco and global warming, it was always the same argument. No matter what the science was, no matter who the scientists were, no matter what agency was funding it, these men always attacked it as insufficient. They always used the tobacco strategy. And they always said that it would be wrong for the government to interfere in the marketplace to control the threat. So as I said, this was the strategy developed by the marketplace, developed by the tobacco industry. And in fact, there's a very infamous memo that has been cited now in a number of books that goes like this. Doubt is our product, since it is the best means of competing with the, quote, body of fact that exists in the minds of the general public. So this was written by a tobacco industry executive in 1969, and this was the strategy that was then applied to all these other campaigns. So this is why we call it doubt mongering. We call the book Merchants of Doubt, because it was all about using this play from the tobacco playbook to use doubt to make people feel that it would be too soon to act on a problem. So if doubt was the product, then the question is who supplied it. And this is where scientists became crucial. Because for this doubt mongering to be credible, if a tobacco industry executive got up and said, well, you know, we don't really know whether tobacco kills you, causes lung cancer, emphysema, bronchitis, heart disease, blindness, you know, and so on and so forth, low birth weight babies, sudden infant death syndrome. How many people here know, by the way, that tobacco smoke causes sudden infant death syndrome? Right. I mean, this is an amazing thing that the tobacco industry successfully suppressed in the mid-1990s, but the fact is there's extremely strong epidemiological evidence that sudden infant death syndrome is strongly linked to tobacco smoke in the households. That's an aside. If you have a baby, don't smoke. But none of that would have been credible. I mean, most of us are smart enough to realize that tobacco industry executives have a vested interest, right? So the tobacco industry understood that for these claims to be credible, they had to be supplied by scientists. And so the tobacco industry, going back to the 1950s, hired scientists to do this work. And Frederick Seitz was one of their important people who did this. And he brought that strategy then into these other debates. So to know exactly how they did this, because I was ordered not to speak for 45 minutes, and my editor orders me not to give away the punchline of the book. No, just kidding. Obviously, for the details, you can read the book. But I want to just spend a few minutes now talking about why we fell for it. Why has this strategy been so effective again and again and again over the course of the 50 years? The tobacco industry began doing this in 1954. That's before I was born and before any of you guys were born, right? It's a long time ago. This has been going on for half a century. So why did we fall for it, and why do we keep falling for it? Well, in part, we keep falling for it because we haven't connected the dots. We haven't seen the bigger picture, and we haven't realized, many of us who have been involved in one debate, I mean, a typical scientist might be doing work on acid rain. He isn't also going to be doing work on secondhand smoke, right? An individual environmentalist might have been involved in the ozone hole, wouldn't necessarily have been involved with secondhand smoke. So part of what we try to do in the book is to show the pattern, to show the big picture and to connect the dots. And so I think that's an important part of why we fell for it, because we haven't up until now really had the capacity to connect the dots. But we also fell for it, we argue, because we have a wrong view of science. Because we've been taught a wrong view of science in school and in our textbook. And that wrong view is that we think that science provides proof. We expect science to provide proof. And therefore, when someone raises doubts, when someone says, oh, but there's this little thing over here that isn't resolved, or there's this question here that people are still uncertain about, or a scientist says, well, it's complicated, right? Then we think that there's something wrong with the science. But what we want to argue is that there's nothing wrong with the science. And in fact, it's what's right with the science, that science, the normal process of doing scientific research, involves engaging with doubt, engaging with uncertainty, but working through it. So we argue then that we need a more realistic view of science, and we call that more realistic view title search realism. So what I'd like to do now then is to do a short reading from the end of the book. And my justification for reading is that I worked so hard in getting this right and explaining it the way I want to, that if I don't read it, I won't be able to get it right. So I hope you won't mind. Oops, sorry. I hope you won't mind hearing a small reading. So imagine a gigantic, colossal banquet. Hundreds of millions of people come to eat. They eat and drink to their heart's content, eating food that is better and more abundant than at the finest tables in ancient Athens or Rome, or even in the palaces of medieval Europe. Then one day, a man arrives wearing a white dinner jacket. He says that he is holding the bill. Not surprisingly, the diners are in shock. Some begin to deny that this is their bill. Others deny that there even is a bill. Still others deny that they partook of the meal. One diner suggests that the man is not really a waiter, but is only trying to get attention for himself or to raise money for his own projects. Finally, the group concludes that if they simply ignore the waiter, he will go away. This is where we stand today on the question of global warming. For the past 150 years, industrial civilization has been dining on the energy stored in fossil fuels, and the bill has now come due. Yet we have sat around the dinner table denying that it is our bill and doubting the credibility of the man who delivered it. The great economist John Maynard Keynes famously summarized all of economic theory in a single phrase: there is no such thing as a free lunch. And he was right. We have experienced prosperity unmatched in human history. We have feasted to our heart's content, but the lunch was not free. So it's not surprising that many of us are in denial. After all, we didn't know that it was a banquet, and we didn't know that there would be a bill. But now we do know. The bill includes acid rain in the ozone hole and the damage produced by DDT. These are the environmental costs of living the way citizens of wealthy developed nations have lived since the Industrial Revolution. Now we either have to pay the price, change the way we do business, or both. No wonder the merchants of doubt have been successful. They've permitted us to think we could ignore the waiter while we haggled about the bill. The failure of the United States to act on global warming, as well as the long delays between when the science was settled and when we acted on tobacco, acid rain, and the ozone hole, are prima facie empirical evidence that doubt mongering works. Decision theory explains why. In their textbook, Understanding Scientific Reasoning, Ron Geary, John Bickel, and Robert Malden show that the outcome of a rational decision theory analysis is that if your knowledge is uncertain, then your best option is generally to do nothing. Doing something has costs, financial, temporal, or opportunity costs. And if you aren't confident that those costs will be repaid in future benefits, you're best off just leaving things alone. If we didn't know that smoking was dangerous, and we did know that it gave us pleasure, we would surely decide to smoke, as millions of Americans did before the 1960s. Uncertainty favors the status quo, and that's why people who want to preserve the status quo emphasize uncertainty. As Geary and his colleagues put it, is it any wonder that those who benefit the most from continuing to do nothing emphasize the controversy among scientists and the need for continued research? To change the way the problem of global warming looks, Geary and his colleagues conclude, you need, quote, undeniable evidence both that doing nothing will lead to warming and that doing something could prevent it. But as we have seen, any evidence can be denied by parties sufficiently determined. And you can never prove anything about the future. You just have to wait and see. So the question becomes, why do we expect undeniable evidence in the first place? The protagonists of our story merchandise doubt because they realized, with or without the help of academic decision theory, that doubt mongering works. And it works in part because we have an erroneous view of science. We think that science provides certainty. So if we lack certainty, we think that something is wrong with the science. This view that science could provide certainty is an old one, but it was most clearly articulated by the late 19th century positivists who held out a dream of a positive knowledge in the familiar sense of absolutely positively true. But if we've learned anything since the 19th century, it's that the positivist dream was exactly that, a dream. History shows us clearly that science does not provide certainty. It does not provide proof. What it provides us with is the consensus of experts based on the organized accumulation and scrutiny of evidence. Hearing both sides of an issue makes sense when debating politics in a two-party system, but there's a problem when it's applied to science. When a scientific question is unanswered, there may be 3, 4, or a dozen competing hypotheses, which are then investigated through research. Or there may be just one generally accepted working hypothesis, but with several important variations or differences in emphasis. When geologists debated continental drift in the 1940s, Harvard professor Marlon Billings taught his students no less than 19 different possible explanations for the phenomenon that drift theory, later plate tectonics, was intended to explain. Research does not provide proof. What it provides is evidence. And in time, that evidence may settle the question, as it did in the case of continental drift. After that point, there are no sides. There is simply accepted scientific knowledge. There may still, of course, be questions that remain unanswered, to which scientists turn their attention. But for the question that has been answered, such as whether or not continents move, then there is simply the consensus of expert opinion. That is what scientific knowledge is. And in the continental drift debate, after a certain point, scientists stopped debating whether or not continents moved and moved on to other questions. Yet most of us don't understand this. If we read an article in the newspaper presenting 2 opposing viewpoints, we tend to assume that both probably have some validity. And we tend to think it would be wrong to shut one side down. But often one side is represented only by a single, quote, expert, or, as we saw in our story, one or two or maybe three. And often those so-called experts are not, in fact, experts at all. When it came to global warming, we saw how the views of Seitz, Nirenberg, Singer, and a handful of others who were not climate scientists, we saw how their views were juxtaposed against the collective wisdom of the entire Intergovernmental Panel on Climate Change, an organization that encompassed the work and views of thousands of climate scientists around the globe, men and women of diverse nationality, temperament, and political persuasion. And this leads to another important point, that modern science is a collective enterprise. For many of us, the word science does not actually conjure visions of science, it conjures visions of scientists. We think of the great men of science, Galileo, Newton, Darwin, Einstein, and we imagine them as heroic individuals, often misunderstood, who had to fight against conventional wisdom or institutions to gain appreciation for their radical new ideas. To be sure, brilliant individuals are an important part of the history of science. Men like Newton and Darwin deserve the place in history that they hold. But if you ask a historian of science, when did modern science begin, she would not cite the birth of Galileo or Copernicus or Newton. More likely, she would discuss the origins of scientific institutions. From its earliest days, science has been associated with institutions. The Académie des Lincei, founded in 1609, the Royal Society in Britain, founded in 1660, the Académie des Sciences in France, founded in 1666, because scholars understood that to create new knowledge, they needed a means to test each other's claims. Medieval learning had focused largely on the study of ancient texts, the preservation of ancient wisdom, and the appreciation of texts of revelation. But later scholars began to feel that the world needed something more. One needed to make room for new knowledge. But once one opened the door to new knowledge, there was no limit to the claims that might be put forth. So one needed a mechanism to vet those claims. These were the origins of the institutional structures that we now take for granted in contemporary science, journals, conferences, and peer review, so that claims can be reported clearly and subject to rigorous scrutiny. Now, science, of course, has grown more than exponentially since the 1600s, but the basic idea has remained the same, that scientific ideas must be supported by evidence, and they must be subject to scrutiny where they can be accepted, rejected, or continued to be studied. Until a claim passes the judgment of one's peers, that is peer review, a claim is only that, just a claim. What counts as knowledge are the ideas that are accepted by the fellowship of experts, which is why members of the societies are often referred to as fellows. And conversely, if a scientific claim is rejected, the honest scientist is expected to accept that judgment and move on to other things. In science, you don't get to keep harping on a subject until your opponents just give up in exhaustion, although this is clearly what some opponents of global climate science are hoping for, that we'll just all become depressed, demoralized, and exhausted and give up fighting. Now, the he said, she said framework of modern journalism ignores this reality. We tend to think that if someone disagrees, we should give that someone due consideration. We tend to think it's only fair. But what we don't understand is that in many of these cases, that person has actually already received due consideration in the halls of science. When Robert Jastrow and his colleagues first took their claims to the halls of public opinion, rather than the halls of science, they were stepping outside the institutional protocols that for 400 years have tested the veracity of scientific claims. And in fact, many of the claims that these contrarians put forward had in fact already been considered and vetted in the halls of science and failed to pass the test of peer review. At that point, these claims could not really be considered scientific. And our protagonists should have moved on to other things. In a sense, we can say they were poor losers. The umpires had made their call, but the contrarians refused to accept it. Journalists were fooled by these men's stature, and we were all fooled by the assumption that a smart person is smart about everything. Physicists have been consulted on everything from bee colony collapse to spelling reform and the prospects for world peace, and of course, smoking and cancer. But asking a physicist to comment on smoking and cancer is a bit like asking an Air Force captain to comment on the design of a submarine. He might know something about it, but then again, he might not. In any case, he's not the relevant expert. So what do we do? We all have to make decisions every day, and we do so in the face of uncertainty. When we buy a car, when we buy a house, when we choose health insurance or save for retirement, we make decisions and we don't allow uncertainty to paralyze us. But we may rely on people who we think can help. Normally, we try to make decisions based on the best information that we can get about a question. Let's say you need to buy a car. No doubt you will take some test drives, but you'll also talk to friends, especially those who know something about cars. Or maybe you'll read some magazines that evaluate cars, like Consumer Reports or Car and Driver. While you know that magazines can make mistakes and that prices and availability of options can vary, you assume that the information that you find is reasonably accurate and realistic. Call it car and driver realism. But the metaphor isn't quite apt for our discussion because in the end, buying a car is highly subjective, based to a large extent on questions of taste. I can decide what I think is the right car for me, but there are no experiments I can do or observations I can make that will settle the question for others. There is, in the end, no truth of the matter as to what is the best car. So consider a different example. One of the largest financial decisions most of us will make in our lives is the decision to buy a home. When we do, we consider numerous factors: the size and location, access to work, shopping and recreation, safety and security, the quality of local schools, and of course the price. The process of deciding to make an offer can be wrenching, involving, like the car, a host of subjective factors, but with far more at stake. Once we've made the decision to make an offer, however, we need to do one more thing, something to which most of us give really rather little thought, considering how much is at stake. And as we've seen in the recent years, potentially bankruptcy, right? So what is that one more thing we do? We do a title search. Or rather, we hire someone to do a title search. We need to know that the title on the property actually belongs to the person who is selling it, and there are no outstanding claims or liens to stand in the way of our ownership. If the person we hire to do the title search is incompetent or dishonest, we could end up with a financial disaster. Yet we do trust the title search. Why? Why do we trust this process? The short answer is because we don't actually have much choice. Someone has to do the title search, and we do not have the expertise to do it ourselves. We trust someone who is trained, licensed, and experienced to do it for us. The sociologist Michael Smithson has pointed out that all social relations are trust relations. We trust people to do things for us that we can't or don't want to do for ourselves. Indeed, even legal contracts involve a degree of trust because the person involved could always flee to Venezuela. If we don't trust others, or we don't want to relinquish control, we can often do things for ourselves. We can cook our own food, we can clean our own homes, do our own taxes, wash our own cars, even school our own children. But we cannot do our own science. So it comes to this. We must trust our scientific experts on matters of science because there isn't a workable alternative. And because scientists are not, in most cases, licensed, we need to pay attention to who the experts actually are by asking questions about their credentials, their past and current research, the venues in which they're subjecting their claims to scrutiny, and, of course, the sources of financial support. And one thing that's been amazing to me in recent weeks with this whole discussion about the hacked emails is how few reporters or other people have asked, well, who are these people who are claiming that these emails prove this, that, and the other thing? Who are the people who did the hacking? And why are questions not being asked about those people and their credibility? These people are accusing scientists of lacking credibility or being dishonest. But who are the people making the accusations? And why should we believe or trust them, considering that they were responsible for hacking into emails illegally? Now, if the scientific community has been asked to judge a matter, as the National Academy of Sciences routinely is, or if they have self-organized to do so, as in the case of the IPCC, then it makes sense to take the results of their investigations very seriously. These are the title searches of modern science and public policy. It does not make sense to dismiss these results just because some person somewhere doesn't agree. And it especially does not make sense to dismiss the consensus of experts if the dissenter is superannuated, disgruntled, a habitual contrarian, or in the pay of a group with an obvious ideological agenda or vested political or economic interest. Sensible decision-making involves acting on the information we have, even while accepting that it may be imperfect and our decisions may need to be revisited in light of new information. But this is where the history of science comes in. For even if modern science does not give us certainty, it certainly does have a robust track record. We have sent men to the moon, cured diseases, figured out the internal composition of the earth, invented new materials, and built machines to do much of our work for us, all on the basis of modern scientific knowledge. And I might point out also, accurately predicted the tsunami that followed the devastating earthquake in Chile. So although many people died in the earthquake, many more would have died in the tsunami had those warnings not been released. While these practical accomplishments do not prove that our scientific knowledge is true, they do suggest that modern science gives us a pretty decent basis for acting. Now, in the early 1960s, one of the world's leading epidemiologists was initially skeptical of the idea that tobacco was deadly, but then he came around to accepting that the weight of evidence suggested that it was indeed deadly. And in response to those who still doubted the evidence and still insisted that yet more data were needed, he replied, quote, "All scientific work is incomplete, whether it be observational or experimental. All scientific work is liable to be upset or modified by advancing knowledge. But that does not confer upon us a freedom to ignore the knowledge we already have, to postpone action that it appears to demand at a given time. Who knows," asked Robert Browning, "but the world may end tonight." True, but on available evidence, most of us make ready to commute on the 8:30 train the next day. Now, don't get us wrong. Scientists have no special purchase on moral or ethical decisions, and a climate scientist is no more qualified to comment on healthcare reform than a physicist is to judge the causes of bee colony collapse. Indeed, the very features that create expertise in a specialized domain lead to ignorance in many others. And in some cases, lay people, farmers, fishermen, patients, or indigenous peoples may have relevant experiences that scientists can and should learn from. Indeed, in recent years, scientists have begun to recognize this. The Arctic Climate Impact Assessment includes observations gathered from local indigenous groups. So our trust needs to be circumscribed and focused. It needs to be very particular. Blind trust will get us into at least as much trouble as no trust at all. But without some degree of trust in our designated experts, the men and women who have dedicated their lives to sorting out tough questions about the natural world we live in, without some degree of trust, we are paralyzed, in effect not knowing whether to make ready for the morning commute or not. We are left, as Alexis de Tocqueville recognized more than 200 years ago, with nothing but confused clamor. Or as Shakespeare suggested nearly 2 centuries before that, life is reduced to, quote, "a tale told by an idiot, full of sound and fury, signifying nothing." C.P. Snow once argued that foolish faith in authority is the enemy of truth, but so is a foolish cynicism. In writing this book, we have plowed through hundreds of thousands of pages of documents. As historians, during the course of our careers, we have plowed through millions more. Often we find that in the end, it is best to let the witnesses to events speak for themselves. So we close with the comments of S.J. Green, Director of Research for British American Tobacco, who decided finally that what his industry had done was wrong, not just morally, but also intellectually. Quote, "A demand for scientific proof is always a formula for inaction and delay, and usually the first reaction of the guilty. The proper basis for such circumstances is, of course, quite simply that which is reasonable in the circumstances. Or, as Bill Nierenberg put it in A Candid Moment, talking about acid rain, quote, "You just know in your heart that you can't throw 25 million tons a year of sulfates into the Northeast forests and not expect some consequences." We agree. Thank you very much.
Thank you very much. If you have a question, please raise your hand. Amanda will bring you.
Hi, thank you for a wonderful talk. And it was really interesting the way you laid it out. And startling, so to say the least. And I wonder if you would comment on communication. So as I was listening to you, it was clear that the agenda of the folks in the think tank and their goal was to communicate. But there's a whole other side of the scientific community that either didn't have the skill to communicate or failed to do so. And could you talk a little bit about what role that had in this story and how this is playing out?
Sure. Did everyone hear the question about communication? Okay. So yes, and I've been here all day today speaking with students and faculty, and we've talked about this a lot. And so I think it's a really important issue that especially universities, scientific communities really need to think about, which is that scientists generally view it as their job to do the science, to learn about the natural world, but not necessarily their job to communicate it. And I think that has really resulted in a lot of damage being done. Now, obviously not all scientists are great communicators, and as I said this morning, some scientists should not be allowed to talk in public, but it really is important for the scientific community to think more about how to communicate. And the way I view it is, when we think about in a university community, we always say that our mission is research and teaching, but I think we need to broaden what we think of as teaching and to realize that teaching is not just about what goes on in the classroom or the work we do with our graduate students, but that teaching has a broader meaning, which includes giving lectures like this, speaking to local journalists, speaking to local community groups, and realizing that if we don't educate the public at large, then we won't be communicating our message, and much of the good work that our scientists do won't have the impact that it should have.
Hello. Your talk tonight presented what you talked about it as a conspiracy theory, so to speak. I was just curious if you've gotten much feedback, considering those who doubt climate change appear to think that a conspiracy theory is being undergone by scientists, particularly Michael Mann and his group, that we're hiding the truth, we're hiding all the data, and that we're just trying to get funding or things like that.
Right. Well, I mean, this question comes up a lot, and first of all, what I want to say is, I don't use the word conspiracy because conspiracy is a word that cannot really be used without invoking in people's minds the preface criminal, right? So I'm not alleging a criminal conspiracy, but I think the evidence clearly shows that there was an organized effort that involved people who worked together, who had think tanks, who had financial support. In the book, we talk more about the sources of financial support. So it was organized, it was conscious, it was deliberate, and the other piece of your question that I also didn't add is, these people studied communication, too, and they hired PR firms, they hired focus groups in order to better understand how to get their message out, which is something that the scientific community almost never does. So it wasn't a level playing field. Now, these people are now accusing other people of conspiracy, so I think if you read the book, one of the things you'll see is there's unbelievable amounts of projection going on here, right? Everything they did, they accuse scientists of doing. They accuse scientists of being disingenuous, they accuse scientists of having an ulterior motive, a political and ideological agenda, of conspiracies, all of that. And all of it is projection, and they present no evidence whatsoever for these claims. So, you can read my book and judge for yourself whether or not you feel that the evidence that we present is compelling, but we present a lot of evidence based on, 5 years worth of historical research. My argument to them is the argument I would make to any colleague: where is the evidence? And I think what you see is you scratch the surface of any of these claims, and you see they're accusations or allegations that are, in almost all cases, without substantiating evidence. You know, and I, of course, have been attacked as being part of this conspiracy. I was attacked by the Honorable James Inhofe of Oklahoma, who a few years ago accused me of being part of the global liberal conspiracy to bring down global capitalism. And my response to that is, liberals should be so organized.
Thanks for a wonderful lecture. I have a loud voice. I was wondering, as you look back at the ozone, DDT, tobacco things, ultimately government action did happen on those. And are there any lessons from those cases as to when the doubtmongers were stopped?
Yeah, no, it's a really great question. And again, that's what I think is such an important part of the story that we're telling. And again, I didn't have time tonight to talk about the whole acid rain or ozone cases, but again, I think if you see the pattern, you know, different scientists were involved in these different things, and yet the argument made against them was always the same. So, you know, if it's a conspiracy theorist, conspiracy among scientists, it has to include all these different groups of scientists who never even worked together. But yes, I mean, the delay issue is the really crucial part. And you know, one of the important things about delay is that delay can serve people's purposes, even if in the long run, you know, they don't win, right? And so in the case of ozone, I mean, ozone is a very interesting case because it's often put forward as a success story where the science was put forward, there was an international assessment through the Ozone Trends Panel, action was taken, and life was good. And I think in many ways it is a success story, and I think it's important for us to know that there are success stories, that it's not all hopeless, that you can get effective international cooperation, that global governance can work under the right circumstances. But one of the things that the delay did, and I'm not saying whether this is good or bad, it's interesting and it's a subtle thing to think about, the delay enabled the DuPont Corporation to find substitutes for CFCs. And when they found those substitutes, then they withdrew their opposition because they realized they could stay in business, still produce products to do the things they wanted to do, and they had come up with substitutes. So you could argue that in some way the delay was sort of okay, you know, in a way it ended up being a win-win situation because it was a relatively modest delay. It gave DuPont a bit of breathing room and it worked out. I think the problem with global warming, though, is that we've already had 30 years. I mean, this has really been, we've known since the 1970s that this was a problem. And one of the interesting things, I've started looking at some presidential papers, I mean, there were big discussions in the Carter administration about whether the Carter Energy Program should take into account global warming or not. And there was a big fight about this in relation to synfuels. We've had a lot of time, and the corporate world has had time too, but they have, in most cases, not done very much. So I think the lesson that comes from this is that it's about incentives, right? That one of the ironies of the delay is that if we had started putting some steps into place back in 1979 or 85 or 88 or whatever year you want to choose, if we began to gradually phase in a gas tax, let's say, just for example, then there would have actually been more incentives for the private sector to invest in the new technologies because they would have seen that we were clearly moving in that direction. And they would have had time to do it in a relatively easy way because 30 years is a fair amount of time for the corporate sector to respond to an impending regulation. By delaying, by putting it off, by refusing to do anything, we move more and more into the situation of a real crisis. And you know, to me, one of the sad paradoxes of this story is that people like Fred Seitz and Bill Nierenberg, what they feared the most was government regulation. And I think this was honestly the case. I don't think this was disingenuous. I think they really did believe that government intrusion in the marketplace was a kind of slippery slope to socialism. But the paradox is that by stopping any government action of any kind, they've actually increased the likelihood that we would need some kind of really intrusive, heavy-handed intervention. The very thing that they most dreaded is now made more likely by the delay. So I think the lesson of this is incremental steps give people a chance to respond. Incremental steps give people an opportunity to do the right thing. And so these strategies of delay are incredibly hurtful. And a more reasonable kind of middle ground, a moderate middle ground would be to say, look, we do know there's going to be global warming. We know it's coming. It's not catastrophe tomorrow. West Antarctica is not going to break up tomorrow or even in, what was it, 2035, in the IPCC report, right? It's not that. But changes are happening. The sooner we begin to act, the less obtrusive the government action needs to be. So we should have started 30 years ago. We've lost 30 years. Let's start doing something now.
One last question.
Hi. You did a great job of leading us through, you've done a great job of leading us through the theory of global warming and presenting the history of the science behind it. And I think that explaining that predictive power of that theory is really, really powerful thing to do, and you shouldn't underestimate the audience. But the idea that the decision boils down to who has more facts, the idea that the decision boils down to some subjective notion of the motive of the groups involved, I think is a really dangerous, slippery slope. And if you can frame the question in a different way, people like Born Lomborg can scrape up thousands and thousands of facts documenting the supposed opposing side of this issue. If you can frame it and explain it as this really powerful theory that explains more than the opposing arguments, that is falsifiable in a way that the opposing arguments aren't, I think you're on much more solid ground in terms of how you present science.
Well, that's a very complicated suggestion, and I'm not sure that I agree with your characterization of my characterization, which is that the side that has more facts wins. I mean, I actually don't think I said that, because I think I showed the facts are on the side of the scientific community, but the scientific community has not won. I mean, in fact, if I updated the slide about public opinion, the number of Americans who believe that global warming is real has gone down since that, in the last few weeks. I don't update my slides every week, because if I did, I would spend my whole life updating my talks. So I think the scientific community is losing this argument, and that's why I think it's so important that we're here tonight talking about this. So I don't believe that the side that has the most facts wins. I also think you have to be really careful, because Bjorn Lomborg presents himself, and everybody knows who he is, the author of The Skeptical Environmentalist. He presents himself as having more facts, but it isn't true. I mean, I've read The Skeptical Environmentalist, and my graduate students and I spent some time spot checking the footnotes, and a lot of the claims he makes that he claims to be factual, if you look at the footnote is to an editorial or an op-ed piece. It's not actually to scientific research. So it's my personal opinion that the Danish Academy was correct when they found him guilty of academic dishonesty. That's my opinion. But I stand by it. I'm entitled to my opinion, and the Danish Academy had the same view, so I'm not alone. So, I think it's complicated, right? There isn't an easy or simple answer, but that's why, what I try to do in my work is to show the history, to show the way the evidence has come together over time, the way it involves both empirical evidence and theoretical consideration. If I had more time, we could talk about who the IPCC were and how, I think one of the most important things to think about is the IPCC represents scientists from, nearly 200 countries. These scientists do not all have the same political opinions. They do not at all agree about what the right solution to global warming is. When I was in Copenhagen last March for the pre-meeting before COP15, there were all kinds of arguments in the hallways about carbon taxes and cap and trade, and the big exciting session of the meeting was a big debate, a kind of really almost nasty debate between Lord Stern and Bill Nordhaus about cap and trade versus taxation. So there's huge differences of opinion in the scientific community about the political and social dimensions of this problem. But nevertheless, these diverse experts agree in their judgment of the scientific evidence. And I think that's the important take-home for all of us, that we know the science. It's what my own governor said. We know the science, we see the threat. The time for action is now. Thank you very much.
Thank you very much.